Welcome back to the deep dive. It represents a bit of a milestone today. It is February 5th, 2026.
It is. Things are moving fast.
I want you to just stop for a second. Literally pause what you're doing and just look at the digital landscape we are inhabiting right now. We have these just massive intelligence models at our fingertips. The raw cognitive power we have access to today is, it's exponentially higher than what we saw just 2 or 3 years ago in the early GPT days.
It's staggering, isn't it? If you showed a 2023 engineer what we're running on a standard laptop today, they honestly wouldn't believe you.
No way.
The compute density, the reasoning capabilities, it's sci-fi stuff that's just become normal.
Right. But, and this is the massive elephant in the room, but there is this lingering terror, isn't there? We are absolutely terrified to actually give these AIs the keys to the car.
Oh, completely.
We treat them like brilliant interns that we frankly don't trust.
It's the paradox of 2026. We have engines that can drive at 1,000 miles an hour, but we're afraid to take our foot off the brake because the steering wheel is disconnected. We have all the horsepower, but we don't have the steering linkage. We can't actually direct it safely.
That's a great image. It really feels like handing a stranger your unlocked phone and your credit card and just saying, hey, go sort out my life.
Yeah.
Maybe they do it perfectly. Maybe they book you a great vacation and balance your budget.
Or maybe they drain your bank account, text your ex-partner, and delete your entire photo library.
And the worst part? You'd have no idea how they did it. Not really.
That is precisely the issue.
Yeah.
And it's not just a feeling, it's an architectural reality.
Yeah.
Currently, giving an AI, an agent, autonomy to actually execute tasks is fundamentally unsafe by design.
Unsafe by design.
We are operating in a world where these agents execute opaque code. They have side effects we can't see. And if something goes wrong, you cannot rewind the tape to see what happened.
Okay, so today we are doing something a little different. We aren't just reviewing a new model release. We are unpacking a stack of documents, a very dense, very comprehensive technical proposal that claims to solve this specific paralysis.
Yeah, that's foundational stuff.
We are diving into a new infrastructure that separates intelligence from execution. And for you listening, this isn't just about building a better firewall. The source material we have today outlines a completely new operating system for AI.
It really is a paradigm shift. We're moving from the era of, trust me, I'm a friendly AI, to trust the math.
Trust the math. I like that.
It is about changing the fundamental physics of how software agents interact with the real world.
And the mission of this deep dive is really twofold. First, we need to understand how this infrastructure actually solves the safety crisis. We need to get into the nuts and bolts, the architecture.
Yep.
But secondly, and here is where it gets really interesting for me, we're going to look at how this safety layer actually unlocks a decentralized, permissionless explosion of innovation.
This is the part that gets me excited.
We're talking about something similar to the early web, but for autonomous agents.
Exactly. It's about disrupting gatekeepers. It's about organizations choosing their own truth through something called M of N auditors.
We'll get to that. It's fascinating.
And it's about a new economy of trust, one that's powered by a utility token called SafeBox.
SafeBox. I saw that in the notes, and I initially rolled my eyes, thinking, great, another crypto token. But the way it's used here is, it feels different. It seems less like speculation and more like, I don't know, digital plumbing.
It is. It's not about speculation. It's the fuel for the machinery. It's the currency of machine-to-machine reliability.
Okay. We are definitely going to get into the economics of robot money later on. But first, let's unpack the core themes here. Determinism, disrupting gatekeepers, and this new economy of trust. So where do we start?
We have to start with the pain. We have to look at the black box crisis.
Right.
Because if you don't understand why agents are broken today, the solution just sounds like, extra paperwork. You have to feel the burn of the current problem to appreciate the water.
Okay, let's dive into that then. The sources describe current AI agents, and we're talking about things that evolved from AutoGPT or the standard open AI agents of the mid-20s as being caught in a Python script trap. Break that down for us. Why is Python a trap? I thought Python was the language of AI.
It is the language of AI research, absolutely. But think about how an AI agent works right now, or at least how they've worked for the last few years. You give it a goal. Analyze this data and send a report.
Simple enough.
To do that, the AI, the large language model, writes a piece of code. Usually it's Python or JavaScript.
Yeah.
And then it executes that code.
So it just writes a script and runs it.
Yes, but it happens in the background. It's opaque. You don't see the code before it runs. And Python is an incredibly powerful language. It's Turing complete, which means it can basically do anything the computer is capable of.
So it can access the file system?
It can access the file system, it can open network connections, it can modify memory, anything.
Which is great for flexibility, but sounds terrifying for security.
Exactly. That code has side effects.
Yeah.
Maybe it imports a library that has a known vulnerability, a classic supply chain attack.
Okay.
Maybe it sends data to a server you didn't authorize. Maybe it just overwrites a file it wasn't supposed to touch. The source material uses this really powerful phrase here, Dunning-Kruger engineering.
I saw that. That stuck out to me. For anyone who hasn't taken Psych 101, the Dunning-Kruger effect is where people with low ability at a task, overestimate their ability. But here, the source applies it to the engineering process itself.
Right. It's applied to the user and the deployment. You have people who are not software engineers using these incredibly powerful models to build complex workflows.
They're just trying to get a job done.
They're just trying to get a job done. And they're letting the AI generate code that they, the human, don't fully grasp, and then they're pasting it into production environments.
Oh.
The risk there creates a scenario where, and this is a direct quote, one compromised workflow equals a systemic breach.
It's like letting a toddler build your electrical wiring because they found a tutorial on YouTube.
Yes.
It might work for a second. The lights might even turn on. But the house is going to burn down eventually.
And when the house burns down, we hit the second part of this crisis, the forensic nightmare. This is the part that keeps general counsels and chief risk officers awake at night.
Because you can't sue a hallucination. Is that the idea?
Because you can't prove what happened. Currently, in standard AI setups, there is no deterministic replay. If an AI agent deletes a database today, or if it hallucinates a massive financial transaction, you often cannot prove why or how it happened.
Wait, hold on. Let me play devil's advocate here. Can't you just look at the chat logs? You can see the prompt and you can see the result. I asked for X, it gave me Y. Isn't that enough?
You can see the conversation, yes, but you cannot see the state of the machine at the moment of execution.
What do you mean by state?
I mean the specific random seed used by the Python interpreter. The exact network conditions at that millisecond. The versions of all the libraries it imported.
Yeah.
The actual execution, the electrons moving through the processor in that specific moment with those specific variables is gone forever.
It's not legally defensible.
Not even close.
Yeah.
So if I go to a regulator, say, the SEC, and say, my AI didn't mean to commit market manipulation, what are they going to ask for?
They're going to ask for the logs, the decision logic.
And right now, you'd hand them a text file of a chat. That's not proof. That's just hearsay. Regulators need what the source calls technical enforcement primitives.
Primitive, so like building blocks of proof.
Exactly. They need to verify the code that actually ran. Right now, compliance is just checking paperwork and trusting you with good intentions. There is no mathematical proof of innocence.
The sources also mention tools like Zapier or Airflow in this context. Now, we usually think of those as safe, reliable enterprise tools. Why are they getting lumped in with this black box problem?
Well, they are reliable for human-defined workflows. When you set up a Zap, you know what it does. You configured it.
Right.
But when an autonomous AI triggers the Zapier hook, do you know exactly what data flowed through it? Can you cryptographically prove to a judge 3 years from now that the AI didn't send personal identifiable information, PII, to a third party through that hook?
No, you just know the hook fired. You don't have a granular, verifiable log of the payload.
Exactly. They act as black boxes regarding the logic of the data flow. They hide the execution risk. It's the difference between it works and it is provable.
So to wrap up this whole problem statement, it's like you hire an employee who does amazing work. They increase your revenue by 50%, but they refuse to tell you how they did it. They work in a locked room, they leave no paper trail, and they burn their notes at the end of every single day.
And occasionally they might be stealing from the safe or inadvertently leaking your trade secrets to a competitor, but you'd never know.
Not until the subpoena arrives.
That is the state of AI agents today. And that is why enterprises are stalled. They can't scale this because the risk is literally infinite.
Okay, so we have established that the current way is terrifying. Let's talk about the solution. The sources describe a breakthrough architecture. The headline here is separating brains from hands.
This is the core architectural shift. It is the whole ballgame. The proposal is to decouple the intelligence, the large language model that does the thinking and planning, from the execution, the actual doing of the task.
So the AI is like the architect, but it's not allowed to pick up a hammer.
Precisely. The AI thinks inside what the source calls a safe box. It's a sealed, attested environment. The AI cannot touch the world directly. It cannot just write a Python script and run it on your laptop.
So what can it do?
It must use policy-constrained tools.
This brings us to a concept that sounds technical but seems absolutely crucial: metadata versus code. The source says we need to move away from raw scripts to workflows as metadata graphs. I need you to unpack that. What is a metadata graph in plain English?
Okay, think of a script-like Python code as a recipe written in a language that can change on the fly. It says, crack an egg, then maybe check the weather, and if it's raining, throw the egg at the wall.
Right. It's imperative. It orders actions.
Exactly. A metadata graph is more like a blueprint or a flowchart. It describes relationships. Input A connects to tool B, which produces output C.
It sounds like a plumbing diagram.
That's a perfect analogy. A script is water rushing through pipes, where the pipes can spontaneously change shape and direction. A metadata graph is a rigid diagram of where the pipes go. It describes the intent and the structure without containing the volatile execution logic itself.
So I can show a regulator the graph.
The blueprint.
Yes, that's the key. You can show your boss or a compliance officer the graph.
Huh?
Here's the plan. Step A leads to step B using tool C. It is static, it is human readable.
And it prevents that Dunning-Kruger engineering we talked about.
It does, because you aren't inspecting obscure code, you are inspecting a logical flow. You're approving the blueprint, not the individual hammer swings. Okay, this is making sense. And this leads to the 3 layers of safety described in the deck. This seems to be the how of the system. Let's walk through them. First, the declarative layer.
This is the public safe layer. This is where that graph, that blueprint, lives. It includes tool manifests, which are just descriptions of what tools can do, all the policies, and the risk definitions.
And it's declarative, meaning it just describes things. It doesn't do things.
Exactly. It just describes the state of things. Because of that, it is safe to render, safe to share, and safe to inspect. You could publish this layer to the world, and it can't hurt anyone. It's just a description.
Okay, that's layer 1. Layer 2, the execution layer. This is the SafeBox itself.
This is where the rubber meets the road, and this is where the tech gets really interesting. The source specifies a deterministic sandbox, specifically mentioning converting JavaScript to WASM, or WebAssembly.
Why WASM? I hear about WASM in web browsers, for running games and stuff. Why is it here?
WebAssembly is a game changer for security. It was designed from the ground up to run untrusted code from the internet safely inside your browser.
Okay.
It is highly sandboxed by default. It can't access memory outside its own little box. You can't touch files unless you explicitly hand them to it. So in this execution layer, only audited leaf tools are allowed to run inside this WASM environment.
Leaf tools. What does that mean?
A tool that does one specific thing and has no other side effects, like calculate tax or resize image. It's a simple function. The AI can say, use the calculator tool, but it can't say, run this malicious script I just invented. And because it's WASM, we can control every single byte of memory it uses. No raw code exfiltration is even possible.
Wow. Okay, so the AI plans using the graph, and the SafeBox executes using these lockdown WASM tools. And finally, layer 3, the verification layer.
This is the oversight. These are what the source calls analyzer bots. Think of them as digital auditors that watch the whole process. They generate metadata, they classify risk, and they tag policies onto the workflows.
So they aren't doing the work.
No, they're watching the work being done. They're the inspectors.
I like the analogy of the construction site here. The AI is the architect drawing the blueprints. That's the declarative layer.
Yep.
The SafeBox is the construction site itself, the execution layer, but it's a site where only certified, pre-approved equipment is allowed. You can't just bring in a flamethrower from home.
Right. And the verification layer is the building inspector standing there with a clipboard, checking every bolt and every beam against the code, ensuring the architect's plan is actually what's being built.
This structure seems so logical, but the real magic word in this entire document, the one that seems to unlock everything else, is determinism. The source calls it the time machine for compliance. Now, we've thrown that word around a bit, but what does it actually mean in this context?
Determinism is one of those words that sounds dry, but in computer science, it is the holy grail for safety and provability. That means same input implies same output every single time, no matter what time of day, no matter what machine it's running on, no matter who runs it. 1 + 1 always equals 2.
It sounds so simple. Why is that so revolutionary for AI?
Because LLMs, the brains, are inherently non-deterministic. You ask ChatGPT the same question twice, you might get 2 slightly different answers. It's probabilistic.
Right.
That is acceptable for a chatbot or a creative writing assistant. It's completely unacceptable for a financial controller or a medical diagnostic tool.
Right. You definitely do not want creative accounting.
Exactly. So this infrastructure forces determinism on the execution. Even if the AI thinks a bit differently each time, the tools it uses in the SafeBox must behave deterministically. And this is what enables a full forensic replay.
A full replay.
Every action is logged cryptographically. If something goes wrong, you don't just have a log file that says error. You can literally replay the entire chain of events exactly as they happened, mathematically proving what occurred.
So it really is a time machine. You can go back to the moment of the crime, so to speak.
And relive it. You can inspect the variables, the inputs, the tool versions, everything.
This links to another term in the stack that caught my eye, runtime attestation. And they specifically reference Nitro. Now, Nitro is an AWS thing, isn't it?
It is, but the concept is broader than just AWS. Nitro is a technology that provides isolated execution environments. We call them enclaves. But the key concept here is attestation.
Okay.
It's a way for a computer to prove to another computer, cryptographically, I am running exactly the software I claim to be running, and nothing else is tampered with it.
So it's like a digital ID card for a piece of software that can't be faked.
It's stronger than an ID card. An ID card can be forged. This is a cryptographic proof that is signed by the hardware itself. You can't fake it. It creates a chain of custody. We can track the AI's actions, linking them to specific model versions, specific random seeds, specific tool versions.
This is why the source claims this wins. This is what enables legal defensibility.
This is everything. If you are a bank, or a hospital, or an insurance company, this is the difference between AI being a cool toy and AI being a regulated, trusted employee.
If an AI creates a liability, you can prove what the AI did and why.
The source calls it the TLS for AI execution.
That's a huge claim. So just like TLS, the little padlock icon in your browser encrypts the web and makes credit card transactions possible.
This makes autonomous AI action possible in high-stakes environments. Without TLS, e-commerce wouldn't exist. Without this kind of SafeBox attestation, the agent economy cannot exist at scale.
Okay, so we've built the fortress, we have the SafeBox, we have the deterministic logs, we have the time machine, but who makes the rules? This is where we get into the really disruptive stuff. This isn't just about safety anymore, it's about power and control.
Yes, this is section 4 of our analysis. Decentralized governance. This is where it gets really interesting.
The outline talks about policy-native governance and M of N auditors. This sounds a little bit like crypto speak, I have to admit.
It borrows heavily from cryptographic principles, yes, but it applies them to software governance in a really novel way.
So let's start with policy-native. What does that actually mean?
It means the rules aren't just suggestions written in a PDF employee handbook. In a human company, you have a rule: don't embezzle money. But physically, the employee can still embezzle money. They just get in trouble later, if they're caught.
Right. The rule exists in the employee's head and on paper, but not in the physics of the office.
Policy native means the rules are enforceable primitives in the code itself. They are part of the physics. For example, you can have a rule that says read-only tools cannot act.
Meaning?
Meaning, a tool designed to read your email can never, under any circumstances, send an email. Or you can have a policy: no PII to external models.
So if the AI tries to break that rule, if it hallucinates and tries to send the email anyway, the system just says no.
It physically cannot happen. The transaction fails at the code level. The hand refuses to move because the physics of the system forbid it.
That's incredibly reassuring, but the M of N part is where the societal shift really happens. Let's unpack that. M of N.
It stands for M out of N signatures. It's a mechanism for distributing trust. So right now, if you use a plugin in the OpenAI store, you are trusting OpenAI to verify that plugin.
Right. OpenAI is the gatekeeper. They're the bouncer at the door.
They are the gatekeeper. They scan the code. They say it's safe, and you just have to trust them.
And if they miss something, we all suffer. Or if they decide to ban a tool because it competes with them, well, we lose out on innovation.
Exactly. But what if you don't want to trust one giant company? Or what if that company has different incentives than you do? This infrastructure allows organizations to define their own trust lists, similar to the UNL, the unique node list concept, in some blockchain networks like XRP.
Okay, so explain how that works in practice. Give me an example.
An organization, let's say a big hospital network, can say, we don't trust just one auditor. We have a list of 5 trusted auditors. These could be reputable security firms, maybe a university research group, an industry body like the AMA, or even their own internal compliance team.
So they pick their 5. That's the N.
N is 5. And then the organization sets a rule. Any update to this AI medical diagnostic tool must be signed by 3 out of those 5 auditors. M is 3, N is 5.
I see. So if a developer pushes an update to that medical tool, it doesn't just go live. It sits there in a sort of digital quarantine.
It sits there in limbo until Auditor A signs it, then Auditor B signs it, then Auditor C signs it. Click Now. And only now is it live and executable within that hospital's safe boxes.
And this disrupts the gatekeepers.
It shatters them. It moves us from, trust me, I'm Google or OpenAI, to trust the math and the consensus of the auditors you chose.
That is huge. It completely breaks the monopoly on truth and safety. A bank might trust auditors A, B, and C, who are all financial specialists.
Right.
And a hospital might trust auditors X, Y, and Z, who are all IPO and medical data specialists.
You're creating a custom web of trust. It creates a market for auditing and a market for trust itself.
And it allows for a permissionless ecosystem. Anyone, anywhere can build a tool. You don't need permission from a central app store.
You just need to convince enough of the right auditors that your tool is safe and effective. If you get the signatures, you are trusted. It's meritocratic.
This is the decentralized innovation part of the mission. It feels so much like the early web. No one needed permission from, I don't know, AT&T to launch a website. You just did it.
Exactly.
But the early web was also dangerous. This feels like it puts a necessary safety layer on top of that permissionless spirit.
It balances the open, chaotic innovation of the web with the stringent safety requirements of the enterprise. The Thor's puts it perfectly. It's permissionless innovation with permissioned execution.
Wow. The best of both worlds.
It really is.
Okay, now let's talk about how these safe boxes interact with each other. Because they don't just sit in isolation, right? They form a network. And this is where the source introduces the SafeBox economy.
Right. This is where we move from pure safety to commerce. This is the engine that drives collaboration across organizations.
It starts with a zero-trust architecture.
Which means safe boxes do not trust each other by default. Just because my company is friendly with yours doesn't mean our bots trust each other.
So how do they talk?
If my SafeBox wants to talk to yours, they authorize the specific workflow by its unique cryptographic fingerprint.
Yeah.
I know exactly who you are and what piece of code you are running before I engage.
And if my SafeBox wants your SafeBox to do some work, I have to pay for it.
That is the model.
Okay.
The source highlights paid services between SafeBoxes. And the utility token for these machine-to-machine payments is SafeBox.
Okay, walk me through a scenario. Make it real for me.
Imagine you are a pharmaceutical company. You have a SafeBox running a proprietary drug discovery workflow. It's highly confidential, your crown jewels. But you need a very specific, computationally intensive statistical analysis done on a new molecule. You don't have that tool in-house. But a university in Switzerland has a SafeBox with a world-class MFAS audited statistical agent.
Got it. I want their brain power, but I don't want to give them my data permanently, and I definitely don't want them to steal my discovery.
Correct. So your bot messages their bot. It sends a request with very strict embedded policy constraints. Analyze this encrypted data set, do not store it, do not share it with any other service, and return only the final aggregate results.
And how does the university bot prove it won't steal the data? How do I trust it?
Because it's running in a SafeBox with runtime attestation. Before your bot even sends the data, the university bot proves to it, cryptographically, I am running the no storage, no share version 3.1 of this analysis tool signed by auditors X, Y, and Z. Your bot verifies that proof instantly.
That's amazing. So trust is established through math, not a contract.
Exactly. Then the university bot performs the work in its own deterministic sandbox, proves cryptographically that it followed every single policy, and sends back the result.
And my bot pays their bot in SafeBox.
Instantly. It's a micropayment that's settled at the moment the service is rendered.
Yeah.
No invoices, no net 30 payment terms, just code execution and value exchange. It's an automated economy of agents.
That is fascinating. It creates all these new revenue layers. Tool registry fees, premium analyzer tooling, compute costs.
It unleashes innovation because it allows for granular specialization. You can build an entire business just by creating one really excellent audited tool, say a financial document anonymizer that guarantees zero data retention, and other agents around the world can hire your tool for milliseconds at a time.
It's the API economy on steroids. It's not just connecting applications, it's creating a marketplace of autonomous services.
You could call it the gig economy for software. Agents for hire.
The source also mentions cubic streams here. What role do they play in all this?
From the documents, cubic streams appear to be the transport layer. They provide the secure, auditable communication channels between the safe boxes. So they handle the access control, the logging, and the governance for the data while it's in transit.
So even the pipes are secure.
Even the pipes. And they also mentioned third-party plugins being isolated via iframes.
Which is a classic web security technique.
Right. It means you can have a rich user interface, a full-stack microservices ecosystem per SafeBox without risking the host system. It's all about containment at every level.
I love this vision. It creates a web of trust. The source says on-premise safe boxes can form private webs-like intranets of trusted agents. And cloud safe boxes can form public webs. It's the internet of agents.
Exactly. And it scales the way the internet scales through decentralized protocols, not the way a monolithic centralized platform scales.
Okay, so zooming out, let's get to the final section. The operating system for AI. Why does this win? We have Claude Cowork, we have OpenAI agents, we have Microsoft Copilot, all these RPA bots. Why is this infrastructure the ultimate winner?
Because the competitors, Claude Cowork, OpenAI agents, they're impressive, but they're fundamentally application layer solutions. They lack the foundational safety layer we've been talking about.
So they're still running in that black box model.
They are. They lack formal decentralized governance. They lack full forensic replay. They lack runtime attestation.
They're trust us models.
They're trust us models, exactly.
Yeah.
The advantage of this SafeBox infrastructure is what the source calls verifiable containment. It's not just about doing the job, it's about proving the job was done safely. For a Fortune 500 company or a government agency or a hospital, that's the only thing that matters at the end of the day.
And the source has a really interesting strategic narrative for the giants, for Anthropic and OpenAI. Why would they want this? Wouldn't they want to own the whole stack themselves?
You'd think so, but what's their biggest blocker to growth right now? It's enterprise safety. Enterprise adoption is stalled because of safety, liability, and compliance fears. OpenAI does not want to be liable if a bank uses GPT-6 and it hallucinates and loses $1 billion.
So this infrastructure solves that problem for them. It's a get-out-of-jail-free card.
It reduces their reputational and financial risk immensely. It effectively offloads the governance complexity to this infrastructure layer.
Right. OpenAI can then say, we provide the brain, the best, most powerful LLM in the world, but you, the customer, control the hands via this SafeBox infrastructure that you configure with your own policies and auditors.
It allows them to ship powerful frontier models, even models that might be a little unpredictable, without being sued into oblivion because the execution was constrained by the policies you set.
The model might have suggested sending the money to a Nigerian prince.
Not the SafeBox blocked it because it violated the no unauthorized international transfers policy. The brain can be wild as long as the hands are in cuffs.
That makes total sense. It's a liability shield, and it creates network effects, right?
Massive network effects. A central taxonomy of tools, shared audit frameworks, a shared policy language. The source compares it to TLS.
That's a bold comparison. TLS is the absolute standard for secure web browsing.
And this aims to be the standard for AI execution. Once regulators realize this level of control is possible, that you can have deterministic logs, that you can have cryptographic attestation, they might start to mandate it.
We demand to see the SafeBox logs. I can absolutely hear the congressional hearings now.
It becomes the path of least resistance for compliance. And at some point, if you aren't using SafeBoxes for your critical AI workflows, you are being negligent.
Okay, so wrapping this all up, this is a big claim. The source says this is not just another agent framework. It is the missing safety layer for AI at scale.
It's a fundamental shift. We are transitioning from uncontrolled code execution, which is the Wild West we live in now, to governable infrastructure.
So for the learner listening today, for the person just trying to understand this, this is the explanation for how we avoid the sci-fi nightmare of a rogue AI.
Right.
It's not about teaching the AI ethics in a philosophical sense. It's about putting the AI in a box where it physically cannot be unethical based on our rules.
It's containment. It's physics, not philosophy.
And for the innovator, for the builder out there, this is the toolkit. This is the foundation for the next generation of decentralized applications. You can build entire businesses on this SafeBox economy.
It really is a vision of the future that feels manageable.
Yeah.
It feels human-centric, which is a nice change of pace.
It puts the control back in human hands, or rather in the hands of the auditors and policies that humans define.
Precisely.
So here is the final provocative thought I want to leave you with today. We used to worry that AI would become too smart to control. We had this fear that it would outthink us, that it would escape the box.
But with an infrastructure like this, the question isn't how smart the AI is. The AI can be a superintelligence. It doesn't matter.
What matters is who holds the keys to the SafeBox, and which auditors do you trust to sign off on reality?
In a world of M of N governance, your choice of auditors literally defines your truth. That is a powerful responsibility for every organization and maybe even every individual.
Think about that. The power of M of N governance in your own life. Who are your auditors? Who are you trusting to verify your world? Thanks for listening to The Deep Dive. We'll see you next time.